The hard part is going to be if you choose to do one like this by hand. It still is very doable, though. I don't think it's any more complicated than when we did this using Z's. So by hand, you'd also want to say, what information did they give me on this one? Well, unfortunately on this one, they gave us a list of information. So we have a list. So we'd actually have to do some stuff on our calculator to figure out some information first. We would actually want to run what's called a one variable stats on this. We did this way back when on your first test back in chapter 3. So we still would have to use our calculator to go over to edit. So, press the stat key first. Go over and then you'd be right on the edit screen, so you'd choose edit. Then you'd want to put in all your data just like if you were using your calculator before. You would input all your data and look like the following. And then you would press the stat key one more time. So after this, you'd press the stat key one more time. But this time you'd arrow to the right once to go over to calculate, and you would choose the first option, which is a one variable stats. Then what the calculator would give us would be the following. The question is, what do we need from it? Well, we're not going to know until we look at our error formula. So let's look at our error formula. Our error formula is T sub C S over the square root of n. Remember, we're using the error formula. It has T's in it because we don't have sigma. We can't use the one with Z's this time. So what do we need? Well, we know that we're going to definitely need that X bar, the sample mean, because that's what goes in the middle of our confidence interval when we go to build it. So we know we're going to need that. So we will need that mean, and I'm going to go ahead and write that down, 0.72, before we even get started, because we are going to use that. Notice, according to the formula, I also need a sample standard deviation, S, which is there. That's our SX we learned, which is our 0.37, and I would be careful on how you round. I would be more generous if you're concerned, because my math lab, if you round it too quickly, sometimes it'll throw off your answer. So you might want to go 0.366. It also tells us our n, our sample size, was 7. So we'd be plugging in a square root of 7 on the bottom here. The thing that we haven't talked about is how to find your critical value if we have T's. That's kind of the new part. So, but we can do that. So let's see the two different ways for finding your critical value, the T sub C. So in order to get our T value that we need to create our confidence interval, we're going to start out with our normal distribution curve, like we normally do. And then what we will do is we will go ahead and fill in our confidence level. Remember, our confidence level here was 90%. Remember, the confidence level being 90% or 0.90 tells us that that's the area that's going to be in the middle, because remember, a confidence interval has got two ends, and we're talking about what's going to be in the middle is the 90% that we have when we're given a confidence level. So let's fill that in, and then our 90% or 0.90 will go in the middle. And then that means what we're looking for is we want to find the T sub C, the critical value. That's the C standing for critical value, the T value that corresponds to this picture. Well, then remember, this is going to work a lot like the inverse norm function, except for it's going to be called the inverse t function. And the first thing it's going to want you to give it, just like the inverse norm function, is an area to the left. So we need to come up with an area to the left first. Well, we don't have the entire area to the left. What we do have is part of it. So 0.90 is what's in the middle. Then that means between the two ends together, the other 0.10 is what's going to be between both ends, which means that each end separately will be just half of that, which is 0.05. Which means that the entire area to the left is going to include the 0.90 and the 0.05 added up, which would be the 0.95. That will be your area to the left that we will input into our inverse t function. Now, there is one more extra thing that the inverse t needs, and it's called the degrees of freedom. Well, the degrees of freedom here are based on n. We'll use df for degrees of freedom. Will be n minus 1. Well, our n on this one is 7, so it'll be 7 minus 1, which is 6. So that's what's going to go in our last slot always, is our degrees of freedom when we're doing our inverse t. Now, inverse norm didn't require degrees of freedom, and that's okay. So, but you're going to get to the inverse t on your calculator by doing that second, then your distribution, and you're going to go find the inverse t, which should be right below the inverse norm. And let's see what we end up with. We end up with 1.943. Let's see what it looks like. So what you'll see is when you go and use your inverse t function on your calculator, this is what you're going to have your output as. And you'll round, and you'll get a t sub c of 1.943. That's your critical value. Now the question is, what do you do with your critical value? Well, you have to go ahead and use it in your formula. Now, however, if you're one of those people who did not have an inverse t function on your calculator, because I do believe that the inverse t function is only on the TI-84, don't panic. I will cover that in just a moment. So remember, the point of finding this t sub c, this critical value, was to find the error formula and have all the values for that, which started out with the t sub c, the s over the square root of n. Well, now we have that the t sub c here is, we just found it was 1.943. And we already had the standard deviation, the S for the sample, which was 0.366 divided by, and remember what goes on the bottom was that square root of n. So that should be, remember, n, not the degrees of freedom, n was 7. So we'd start off by doing the 1.943 times the 0.366, and then at the end, we'll divide by the square root of 7, and let's see what you end up with. You end up with the following. We get 0.27, and remember, that's our margin of error. So to actually figure out what our confidence interval is going to look like, let's go ahead and draw our picture again. Well, remember, what goes in the center of our confidence interval is our mean, which we said was, let's see, 0.72. Then we just found the error. It was 0.27, so we'd take the 0.72 and add the error for the top end, so add the 0.27, which ends up being 0.99 on the top end. And then on the lower end, we take the mean, the 0.72, and subtract the error, subtract the 0.27, which gets us a 0.45 as our lower end. So that means our confidence interval for mu, for the population mean, starts at 0.45 to 0.99. And that would be our final answer. Now, that shows us how to do this problem by hand.